rest mass, electrons spin like gyroscopes following polyhedral geometry, primarily based on 3 axes of symmetry, 4 axes of symmetry, and 6 axes of symmetry. This is also seen in crystallography. The electrons are located at either a polyhedral vertex or at the center of a polyhedral face. The electrons spin in pairs, and this could connect to action at a distance. We believe that the wave-particle duality is, in reality, the profile of a spinning electron, and if viewed with depth information, would reveal a corkscrew motion. The line between the pairs of electrons is a polyhedral axis of symmetry with the nucleus at the center. This is confusing, so try this at home. When you demonstrate the spinning pairs of electrons where both electrons in the pair are spinning in the same direction, it is hard to tell if they are spinning clockwise or counterclockwise. So try this at home. When you observe your left hand from the outside, the electron appears to be spinning counterclockwise. And when you keep the same motion and you observe your right hand from the outside, the electron appears to be moving clockwise. So to simplify this confusion, we say half of the pairs spin in one direction and half of the pairs spin in the opposite direction, and this is what keeps the atom in balance and holds the electrons in place at rest mass. Also in balance is the electromagnetic force radiating from the nucleus to the electron and returning from the electron to the nucleus as quantum loop gravity, an infinity symbol. Out to the electron, back to the nucleus, out to the electron, back to the nucleus. So half of the electromagnetic force radiates from the nucleus to the electron and drives it to spin, and half of the electromagnetic force returns from the electron to the nucleus as quantum gravity. So the energy that radiates from the nucleus to the electron and drives it to spin does so along the 6 axes of symmetry. Here in this cube octahedral model would be these lines here. The electromagnetic force that returns from the electron to the nucleus does so along the Cartesian XYZ dimensions, which is through the center of the square faces of the cube octahedron. So here is X and Y and Z for the location of quantum gravity. We believe that in addition to the Cartesian dimensions that scientists currently use, we must observe the atom with these 6 dimensions in order to locate the atomic particles.
The periodic table that we're developing could be used by chemists, scientists, mathematicians, physicists, organic chemists. So what we did is we applied tetrahedrons and octahedrons and cube octahedrons and rhombic dodecahedrons and for the positions of the electrons in the atom.
We present a paradigm shift for the concept of atomic mass, whereby it is related to the number of nucleons. We are normalizing the standard model for quantum theory by orienting gravity within subatomic particles. We accept the nucleons as a combination of up-down quarks representing protons and neutrons. We hypothesize that the strong force could be generated by positive and negative charges within spinning quarks, which connect to the electrons through quantum loop gravity. The tetrahedral-octahedral packing of the nucleus accurately represents atomic mass for all isotopes. This explains why cerium-140 has a greater atomic mass than barium-140. We see that the quantity of triangular planes represents atomic mass. Our 6-dimensional periodic table for the nucleus is a work in progress, and we continue to discover the geometry of more isotopes. We are presenting that everything in nature is composed of the equilateral triangle and the tetrahedron octahedron truss. Everything is triangles, and triangles are everywhere. The collection of everyone taking this back to their desk is the revolution. We can do this.